We're going to continue to look at view factors, and we're going to talk about the reciprocity relationship. And the reciprocity relationship says that area 1 times view factor 1 to 2 is equal to area 2 view factor 2 to 1. And of course, it's easy to remember the order. The area 1 always goes with the first number in the view factor on the left and on the right. And you can use this relationship to find other view factors. If you have 1 to 2, you can find 2 to 1. If you have 2 to 1, you find 1 to 2. And in general, this will work for any values. In other words, let's say you have just a general I, then Fi to J is going to be equal to J Fj to I. So you can find any kind of relationship like that. Another important thing we want to talk about is decomposition. And so suppose you have some surface down here, let's call it number 1, and some other surface out here, call this number 2. Let's call this whole thing number 2. But let's say number 2 is broken up into a couple of parts. Maybe call this 2A and 2B. And decomposition says that the view factor from 1 to 2 is going to be equal to the view factor from 1 to 2A plus the view factor from 1 to 2B, like this. That's an important relationship. That, along with the reciprocity relationship, can often help us to solve problems in which we know a couple of the view factors, but not the other one. And of course, it can be extended that if you have your second surface broken up into more parts, it works the same way. Say this is 2A, 2B, 2C, 2D. Then, again, we can still say that the view factor from 1 to 2 is equal to the sum to the sum of the other view factors. So F1 to 2 is equal to the sum of 1 to 2A, 2B, 2C, and 2D. And we're going to do some examples in a minute here. One thing I want to mention about reciprocity is that, we have this relationship, but often what we want to do is rearrange these. So, for example, often we want to find, let's say, F1 to 2, and then just solve this way, like this. And then in general, once again, if you have a I, F, I to J, A J, F, J to I. Once again, let's say if you want to solve for, and suppose you want to solve for F I to J, you again just divide by AI. Of course, always remember when you're solving for the view factors, when you're using reciprocity relation, the area will always be multiplied again by the first number. So the area 2 will be times F2 to 1. Or down here, area J will be from F J to I. In other words, these will always match the first number. Again, you can use this anytime. Again, like I said, if we have one or another example, let's say if you have A6 times A6 to 3, F6 to 3, that's going to be equal to A3, F3 to 6. And again, sometimes maybe we'll want F3 to 6. Again, just solve that. A6, F6 to 3 divided by A3. Again, these will always match. So again, we're going to use that a lot when we use this reciprocity relationship. This will often be the form that we're going to use it for. We want to solve for one of these view factors given the other one. Let's take a look at this problem. Consider the two surfaces below. The upper surface is aligned directly above the lower surface. Find view factor 1 to 4. And so notice what we have. 1 is over here, right above 3. 2 is over here, right above 4. Now, if it would have asked us for the view factor 1 to 3, they've been real easy because one surface is above the other. We could have just looked it up on the chart. They're both exactly the same size. Everything would have been good. Same thing over here. If we would have been asked for the view factor 2 to 4, it would also be easy because 2 is directly above 4, and they're both the same size. We could just look it up in the chart. But in this case, 1 is above 3 and 4 is below 2. So things don't work out exactly right because 1 is not directly above 4. So we're going to have to do this a little bit different way. So we're going to start solving this, and we're going to start by using decomposition. We're going to say that F1 plus 2, in other words, the view factor from here to here, is going to be equal to the view factor from this one to 3 plus this one to 4, like this. But remember, that was decomposition we looked at a few minutes ago. And then the other thing to notice is that this view factor from here to 3 is going to be exactly the same as this view factor from this to 4. In other words, these two are going to be the same because they're both are the same size. Everything's broken up in the same dimensions. And so these two are going to be the same. Now, we have ultimately want to get a 4 involved. So since these are the same, we'll write these as 2 F1 plus 2 to 4, like this. And now if we continue on, we would like to eventually be able to decompose again, but we need to reverse the order of this here. So remember, using reciprocity, we can write this as A4 F4 to 1 plus 2 divided by A1 plus 2. That's just using reciprocity. And now notice, though, that A1 plus 2 up here, these two surfaces together are just double the area of 4. In other words, the area of 4 is going to be 15 times 8. The area of 1 and 2 is going to be 15 times 8 plus 8. So this area is double the area of 4. So we could, furthermore, get a 4 in here. We could say that this 2A1 plus 2, excuse me, A1 plus 2 is going to be equal to 2A4. And now the 2's cancel and the 4's cancel. So then we're left with this. So now what do we have? That this is equal to this. So writing down we just found this relationship. And now on the right-hand side, we can use decomposition over here. And so that's going to be the same as 4 to 1 and 4 to 2. And let me just rewrite the left-hand side down here. And now let's think about this just for a minute. If we consider our table, we can find this left-hand side here because that's just this whole big plate over this whole big plate. We can find that in the table. And now F4 to 1 we can't find because the one is not over the other. But F4 to 2, we can find that because that's just going to be one plate directly over the other. So let's think about what we have. So let's actually make just a real quick picture. That's not very good, but that's going to be 1 to 2 and 3 to 4. And again, that's going to be like a total of 16 inches, 16 inches. And this is 1 plus 2 up here, 3 plus 4. And what they were 15 inches wide like this. So that's going to be this side over here. Then over on this side here, what is this going to be? This is the one we're going to be able to find. So we're going to put 2 up above and 4 below. And you probably don't have to actually even draw these extra pictures, but you can just do the calculations. But I just want to do this to emphasize what we have. Once again, 2 is directly above 4. And would we say the distance here was 10 inches? Distance here was 10 inches. And again, these are both 15 inches here, 15 inches here. And now we're going to have to find the table for with view factors. And I'm using the book by Kaminsky and Jensen, Introduction to Thermofluids. Uh, but you don't have to use this book. A lot of other books have. There's an excellent book on thermal fluids. And if you are using this book, if you look at this table here, now my edition, which I believe is the first edition, it's table 14-16, and it has two plates, two parallel plates, one directly above the other. And that's what we have in both cases here. Here we have two plates, one directly above the other. Here we have two plates directly above the other. And so the length X, it needs X, Y, and L. X over here is 15 inches. Y is 16 inches. And it also wants the distance L between the plates, which is 10 inches. And the same thing over here. We're going to have X equal, in this case, it's also 15. And Y this time is 8 inches. And the distance between it to the length is still 10 inches. And also, according to our chart here, we need X over L, and we also need Y over L. So X over L is going to be 15 over 10. X over L is 1.5. Y over L is 1.6. And over on this side here, X over L is going to be 1.5 again. And Y over L going to be 0.8. Now for this over here, again, if we look at our figure, again, in my book, this is figure 14-16. And so that's, again, this is going to be our F 1 plus 2 to 3 plus 4. And we have 1.5 and 1.6. Again, 1.5 down here. And 1.6 is going to be between these two curves here. And if we keep going up to here, I'm going to estimate that as about 0.33. Again, I want 1.5. Then 1.6 is between these two curves. So I'm right like over here. Maybe 0.32. It's just a rough guess. 0.32. Then for this one over here, 1.5 and 0.8. And 0.8 is going to be between these two. Maybe about right there. This is maybe going to be point, maybe point 22. So F4 to 2 is 0.22. And I kind of look back at the chart again. Maybe this one was 0.31. But it's kind of hard to read these curves exactly, but I'll go to 0.31. Now we're going to go back and substitute those into this equation. So if we substitute those values back in here, and that's going to be F4 to 1 is going to be 0.09. Now, uh, it's actually going to be the case F4 to 1 is the same as F1 to 4. Now, that's not always going to be the case. In fact, most of the vast majority of the time, it's not going to be. But it happens to be that they both have the same area. So remember, if we have F41 is going to be equal to A1 F1 to 4 divided by A4, but those two areas are exactly the same. If you look back over here, 1 and 4 are exactly the same areas, are both 15 by 8. So those are gonna cancel. And so we're gonna have that F41 is equal to F1 to 4. So that means up here, F1 to 4 is going to be equal to F4 to 1, and that's to our 0.09.